Good morning, everyone. Today I'm going to be talking to you about light. This is presented to you by Judy. What is light? It is an electromagnetic radiation that can be detected by the human eye. Light consists of photons, which are produced when an object's atom heat up. Light travels in waves, and it is the only form of energy visible to human eye. What are photons? Photons is a type of elementary particle. It is the quantum of the electromagnetic field, including electromagnetic radiation such as light and radio waves, and the force carrier for the electromagnetic force. Photons are massless, so they always move at the speed of light in vacuum, 300 millimeter per second. Photon can be split, it can only be created or destroyed. How is light created? Light is created when an electron from its excited state returns from a higher orbital. As the electron returns, it sort of sheds its energy, which is called the electron spectra. The spectra is actually light. Light is basically a form of energy given out in the form of packets of energy called photons. How does light reach us? Before exiting our star, which is the sun, each photon must undergo a long journey. Over the course of 40,000 years, it will be absorbed by the other atoms and emitted repeatedly until reaching the sun's surface. Once there, the photons stream out, illuminating Earth, the solar system, and beyond. The number released from the surface every second is so vast that it is more than a billion times greater than the number of grains of sand on our planet. Watch the animation to see how the atoms, even inside the sun's core, melt together and generate light. Why is light called an electromagnetic wave? Scientists call them all electromagnetic radiations. The waves of energy are called electromagnetic because they have oscillating electric and magnetic fields. All electromagnetic energy waves travel at the speed of light, no matter what their frequency or wavelength is. They always move at the same speed. What is the reflection of light? When a ray of light approaches a smooth, polished surface and the light ray bounces back, it's called the reflection of light. The incident light ray, which lands upon the surface, is said to be reflected off the surface. The ray that bounces back is called the reflected ray. If a perpendicular were to be drawn on the reflecting surface, it would be called a normal. The figure below shows the reflection of an incident beam on a plane mirror. Here you can see the incidence ray, the reflected ray, and the normal. This is the mirror, and you can see the incidence angle and the reflected angle. The law of reflection determines that the reflection of an incidence light rays on a reflecting surface like mirrors, smooth metal surfaces, and clear water. Let's consider a plane mirror as shown in the figure above. The law of reflection states that the incidence ray, the refracted ray, and the normal all lie on the same plane. The angle of incidence is equal to the angle of reflection. All about mirrors. When an object is reflected in a plane mirror, its image is the same size as the object, the same distance between the mirror as the object in front of it, and the left right, and it is left right inverted, and it is virtual. Refraction. Refraction is the bending of light when they travel from one material to another. The ray bends towards the normal when entering the glass, its speed decreases, and the ray bends away from the normal when leaving the glass, its speed increases. Refraction conditions. When the ray enters in an angle into the glass, it refracts. But when it enters in a straight line, perpendicular to the normal, it will not refract. Here we can see when it enters in an angle, the incidence ray, and here the refracted ray is towards the normal, so it's slower, so it enters another material. Here it is refracted, but on the other side it is entering at a straight line, and then when it enters the glass there is no angle, so there's no refraction happening over here. Refractive index, the property of a material that determines the extent which it causes the ray of light to be refracted. Refractive index is equal to the index of refraction is equal to C over V. C is the speed of light in vacuum, and V is the speed of light in medium. Snell's law, it is a law that relates the size of angle of refraction to the angle of incidence. The greater the refractive index is, the more the ray is bent. So the law is the refractive index is equal to the angle of incidence, or sen of the angle of incidence, and then sen r, which is the angle of refraction. Total internal reflection. Total internal reflection in physics is the complete refraction of a ray of light within a medium such as water or glass from the surrounding surface back into the medium. The phenomenon occurs if the angle of incidence is greater than a certain limiting angle called the critical angle. TIR, it's called total because it's 100% reflected. It's called internal because it happens inside of the glass, and it is reflection because it is entirely reflected inside of the glass. More about total internal reflection. If the angle of incidence of a ray at a surface is greater than or equal to the critical angle, it will be totally internally reflected. Glass prism can be shaped to produce the total internal reflection, and such are employed in binoculars, periscopes, telescopes, and other optical instruments. Light rays may be conducted over long twisting paths by multiple total internal reflection in glass or plastic rods or fiber rods. Here we can see the three conditions of the total internal reflection. The first condition, the angle of incidence is smaller than the critical angle, so there's still a refraction in an angle, and there is a reflection angle as well. Here, the incidence angle is equal to the critical angle. If we notice here the refracted angle is at 90 degrees. And here, the incidence angle is more than the critical angle, and in this situation, it is totally internally reflected. Critical angle and refractive index. The greater the refractive angle of the material, the smaller the critical angle. When the critical angle is equal to the incidence, the refracted ray bends through 90 degrees. N is equal to 1 over sine C. You are going to ask, where did we get the 1 from? The 1 is coming from because sine I is equal to 90, so it's going to be sine 90. If you put that to your calculator, you're going to find it to be 1. So basically, it's going to be n is equal to 1 over sine c. Now let's talk about lenses, either the converging lens or the diverging lens. The converging lenses are thicker across the middle and thinner at its edges. It serves to the converged light. Diverging lenses are thinner across the middle and thicker at its edges. Serves to diverge the light. General information about lenses. Focus is the point where the rays are concentrated together. Focal point is the distance from the center of the lens and the principal focus. Here is a figure of the converging lens. Here are the light rays. They entered the converging lens, and then they all concentrated together in the focal point, and then they spread back again. And you can see here the focal length is from the middle of the lens to the focal point. The image of the converging lens is always inverted, which is upside down, reduced, smaller than the object, nearer to the lens than the object, real. And here's a note: real images can be displayed on a screen, while virtuals actually can't, like the mirror ones. Now, if we're talking about the magnifying lenses are also a type of converging lenses. The image of the magnifying lens is slightly different from the converging lens, so it is upright, magnified further from the lens than the object, and it is virtual. Thank you so much for listening to me. This is made by Judy Mohamed Sheikh from grade 9. It is supervised by teacher Rasha Abu Dahab. Thank you so much again, and see you all